So let's start with current presentation. Let me welcome you here on JSON support in Java EE talk. First of all, this is a Herbert statement which I need to use in all presentation. It basically says that you should not trust me in making business decisions. Everything you will find in the presentation is still a work in progress, so may change depending on users and expert group members' input. And everything can change. Shortly about myself, my name is Lukas Jungmann. I work for Oracle for last 5 years or something. Currently, for last month, I started to work on JSON-B and JSON-P specifications. I'm a member of the expert group. Other than that, I'm also specification lead for JPA, but that's another story. I'm still Eclipse Link project committer. In the past, I used to work on a NetBeans project, Glassfish, Metro, JAX-WS, JAX-B, and all web services related technologies. So let's see what we have on our agenda. First of all, there will be some introduction, then we go through JSON processing and JSON binding APIs, and in the end, if time permits, there will be some time for your questions, and I hope also some answers. So let's start. JSON support in Java EE 8 will consist of two parts. First part will be Java JSON processing API. The second part will be JSON binding API. You probably know the former from current Java EE 7, which already contains version 1. It offers standard API to parse, generate, query, and transform JSON documents. It also offers an object model-based API and streaming API, which is similar to DOM and stacks model known from XML world. Another set of APIs which is going to be new in Java EE 8 is JSON binding API, which is very similar to JAX-B. You can find a lot of inspirations from JAX-B even in this API. And basically it allows you to bind JSON documents to Java and vice versa. So let's take a look at JSON processing. The most important class in JSON processing API is JSON. It's this one. Basically, it offers static methods to create particular classes like parser, generator, builder for array, builder for JSON object, and so on. One of those important classes is JSON parser, which allows you to parse JSON object in streaming fashion. It's similar to XML stream reader from XML world. You can create it, as I said, through JSON object, either directly through create parser method or indirectly through a factory. Using the factory has a benefit that it can be customized with optional features. Parser is producing fixed set of events, which I will show on this example. Say we have a document like this. It has some properties, some array, and we want to parse it. So first event we will receive is start object. Then, as we follow, the next event will be key name. Then we get a value string, again key name, value number, because it is integer, so it is recognized as an integer. Then we have key name, start array, start object, key name, key string pair again, and now ending events. It's very similar to XML processing. Now if how we handle this in our code. Basically we create a parser and then we are moving through events with call to next method. So first event will be start object. Then we move next to consume key name. From key name we can get a string to obtain a name of the key. Similarly, move next and get a value. For integer-based, we can just integer-based values. We can just call getIn. That's it. Another important class is JSON generator, which allows you to generate JSON in a streaming fashion. It's similar to XML stream writer. Similarly, as JSON parser can be created using JSON object, either create generator or through the factory. This factory again accepts some optional arguments, some map, which first argument key is a string like name of the optional feature and value is arbitrary. The difference between XML parsing or XML generating and this JSON is that in this case API allows you to chain methods, which can be seen on this example. On the right side we have a simple method or simple code snippet which creates an array with two objects, and the output will be as seen on the left side. Try to remember this example because in a couple of slides there will be similar or different approach to generate the same output. Another set of APIs is Object Model API. It offers builders to build JSON object and JSON array from scratch. It allows method chaining, it's type safe, and can also use existing JSON objects, JSON arrays in a builder. This is very similar to DOM. So, and here we can see the example. The document produced is the same as in previous example, but the code is slightly different. Basically, in this case, we are using array builder, and in array builder, there are two calls to create objects, JSON objects directly. That was present or is still present in Java EE 7 in version 1.0 of JSON-P. In upcoming version 1.1, we are trying to update JSON-P to stay current with existing standards, and new additions were mainly support for JSON pointer, JSON merge, patch, and JSON patch. We've also added editing and transformation operations to JSON objects and arrays, support for streaming API together with collectors, support for processing big JSON. This means that if you have some huge JSON document to process, you don't need to load it as a whole into memory. You can just define a pointer or a filter to parse, to add it to the parser, and you get just a limited subset of the document. Okay, so what's JSON pointer? A JSON pointer is defined by RFC 6901. It defines a syntax to navigate through JSON document. It's kind of similar to XPath. Again, it starts with a slash, which means root of the document, and then names of the properties. Instead of a name of the key, you can use also index number. Everything is indexed from 0 like Java arrays. So second item will always have index 1. And all pointers are absolute. So if we look into example, say we have a JSON document containing two dogs, one Cassidy and Falco, and we think that Falco is not a pug but also an English bulldog. So we want to update that value. So if we want to use JSON pointer, we can just create a pointer to second item, which means number 1, index number 1, and breed. This will return us a pointer pointing to this particular item, and then we can just get a value and update it to what we want. This is one way to modify JSON documents through JSON-P. The other one is using JSON patch. JSON patch is defined by RFC 6902. It defines a format of a JSON document which you can use to modify parts of existing JSON documents. In the predefined format, you need to define an operation which you want to do. There is a fixed set of operation. It's add, replace, remove, copy, test, and move. You can also send the JSON patch document through HTTP directly, which is nice. So if we look at an example we saw before, now there are 3 dogs, and we want to use JSON patch to modify this document. So we, on the right side, we see a sample JSON patch document. First, it's an array containing 2 definitions of 2 operations. First one is replace. It means that for operation replace path, that's format of the path is JSON pointer. So it points to second item in the array and value what should be updated, like new value of the key of the property. Important thing to note here is that operation or OP and path attributes are mandatory in JSON patch. Value is optional depending on the operation. Because for example, in the next operation, which is remove, you don't want to define value, what would be the value if it is going to be removed. So after applying this patch to original document, we end up with something like this. 2 items in an array, both having English bulldog as a breed. Now let's move to JSON binding. This was JSON processing, now JSON binding, which is going to be new in Java EE8. JSON binding or JSON-B offers an API to serialize and deserialize Java objects to and from JSON documents. It's similar to JAX-B, and it basically evolved from existing libraries like Jackson, Jensen, JSON, and few others. It offers or defines default mappings, default behavior. So basically, if you have some existing data model or domain model classes, and you want to get JSON document out of them, you just call the API and it will somehow transforms the classes to JSON document by itself. It offers some customizations APIs and is natural follow on JSON-P. So it's kind of evolution in terms of JSON support. Basically in Java EE7 there was ability just to parse or create or generate JSON documents in EE8, there is going to be also a way to bind Java classes to JSON documents and vice versa. And this is supposed to be an API with some reference implementation, but it's up to you which implementation you would use. So for default mappings, basically, as I mentioned, there are defined sets of default rules. So all you have to do in order to use JSONB is to create JSONB object through static method JSONB builder, and then everything will be handled. I'll go through particular scopes later. But let's take a look what JSONB interface offers. Basically, it's just a set of toJSON and from JSON methods with various arguments. I omitted the throws JSONB exception from the slide. All of these methods are throwing it. It's not here just to make it somehow readable. And the basic and specific types which are supported by default. All basic types, wrappers, or basic types, basically those are wrappers around primitives plus string, and some specific types, basically big integer, big decimal, URL, URI, and optionals. Everything is defined in the JSONB specification. Another set of supported types is date and time. In the first column, you can see supported data types from Java util and Java time packages. And in the second column, there are some defaults. Everything is ISO based, and only one important thing to note here is that if the time does or date doesn't contain time, then it is not serialized by default. That can be seen on these examples. So first one is showing how Java util date is serialized. There is some simple date format, some parsing, and when we call to JSON on this date, we get some date and time is set to midnight. For calendar, if time is not set, time is not serialized. Next three samples shows how to handle how Java time, instant, durable, and period are handled. From collections, more or less all classes, you know, from collections framework are supported. So there's nothing difficult here. Something different from existing implementations is that JSONB provides support to JSONP types. This can be useful mainly where working with custom data, or when you need some customizations to default behavior. The specification also defines what is serialized, deserialized by default, and visibility rules, and so on. So let's start with classes. By default, public and protected nested and static nested classes are serialized, and deserialized. Anonymous classes are only serialized. There is no way to deserialize them by default. There are some options how to achieve that goal, but not by default. Inheritance is supported, and by default it is required to have default no argument constructor. Again, this is default and can be customized. Fields, by default, final fields are serialized, static, transient, null fields are skipped. So no notion about them in final JSON document. Fields are ordered lexicographically, again, can be changed. And parent classes fields are serialized before child classes. So if there is inheritance, parent appears first, and children or child appears next. It can be seen on this example. So say we have parent class with two fields, parent B, parent A. On the right side you can see final JSON document. It will contain parent A and parent B in this order. If we add child, so two additional properties, child B, child A, and in a document we can see that parent is first and child is second. And again, it's lexicographically changed to be lexicographically. This is default. Scope and field access strategy. This is copy from the specification, but basically it says that public fields are serialized and deserialized. Then if there are some methods, like getters, setters for some field which is either public or private, it doesn't matter, there is a method so this method is used to serialize or deserialize data. And you can also have virtual fields, which means that you have getter and setter but no corresponding field to it. JSONB will just call these methods and it is up to you to provide the logic what should happen. We can see that on this example. Say we have some class foo with a bunch of fields. First one is public final, so that's serialized. Private, so not serialized. Third field is static, so by default it is not serialized. Then we have public field with no getter, that is going to be serialized. Then we have public field with private getter. Well, field is public, but rules are defined that methods overrides to some extent this visibility. So if getter is private, nothing is serialized. Nulls are not serialized by default. Private field with no getter, again not serialized. Private field with public getter, so that's clear. And the last example is the virtual field access, which I mentioned. So there is some getter setter with some dummy logic probably, so it gets serialized. And it is up to the user code to provide the value in a getter, through the getter somehow. What I was talking about is default behavior, and basically 99% of the behavior can be configured somehow or customized. So this shows how basically you can use either compile time customizations through annotations or runtime configurations depending on some program input. For that you can use JSONB config and JSONB builder. JSONB config offers a lot of with something methods, and then once you have config you can use a builder with config, and you can also use this with providers. Say you are not satisfied with what Java EE platform provides and you want to use your perfect library, so if it implements JSONP API, then just pass it to with provider and it will be used. This provides summary of all possible customizations, and so let's go quickly through each of it. Property names, you can customize property names. So say you have a class which has a field first name, but you don't want to have first name in your JSON document, you want to use name, so you can use JSON-B property annotation. It can be defined on a field, on a getter, setter, or in a parameter. Property naming strategy, basically default is, I think, as it is found in Java class, but you can define your own strategy if you wish, or implement your own. Property ordering, as I said, the default one is lexicographical from A to Z. You can use reverse or any. It's up to you, basically. But it's a good idea to use default in this particular case. Ignoring properties says sometimes you don't want to expose some properties in a JSON document, and therefore there was added JSON-B transient annotation. It is, again, very similar to transient annotation you may know from JPA, or XML transient known from JAX-B. Maybe this could be somehow improved, like defined on one place. Property visibility, property visibility strategy. You maybe remember that slide I've mentioned, how it works, that fields, public fields, and there are some getters, setters, and so on. Sometimes you need some customized solution. So for that case, you can use property visibility strategy, implement this interface, pass it to the config, and it will be used. So when JSON-B runs the code, then it will be up to you to implement just is visible either field or method and implement your own logic. Null handling, again, by default, null is not serialized, but you can change the default behavior to either through either JSON-B config with null values true, set to true, or directly on the fields or class. In this case, name will be serialized with null as a value. In this case, in the second case, when annotation is applied on a class level, then all fields where it is applicable will use null. Or I think there will be null as a string or something like that. So basically the key will appear in a document and the value will be something, I think it will be as a string null. So when you are deserializing, you can easily identify that it was null before. Custom instantiation is another part. As I mentioned, by default, it is required to have public no-argument constructor, but sometimes it is not possible to add such constructor. So there is a JSON-B creator annotation through which can be used either on a constructor or on a public static method. It's kind of factory method. It can take some arguments, and basically this way you can use arbitrary code basically to serialize or deserialize, in this case, methods. Another customization applies to dates and times, dates and numbers handling. If we have an example like this, default date and default number will use the default, and formatted date and formatted number will use pattern defined in JSON B number format annotation or JSON date format. As every binding framework needs to handle some binary data, so there are 3 supported encodings, byte, which is default, and then base 64 URL. If you want to use base 64, again, use JSON bconfig and pass with binary data strategy and define which one you want to use. One of the most recent additions to current implementation was support for iJSON, which stands for Internet JSON. And it's a restricted profile of JSON defined by Internet Engineering Task Force. JSONB fully supports this with some exceptions by default. But if you really want to strictly follow the profile, just tell it to the config. One of the most important things or most interesting things are adapters, which you may know also from JAX-B or even JPA. It basically allows you to serialize, deserialize, or basically convert arbitrary data yourself. So in this case, we have some animal adapter implementation which is capable of handling some animals, and 2 methods which we have to implement and pass adapters to config. Another approach we can take when dealing with custom data objects or custom data, we can use custom implementations of serializers and deserializers. These classes or implementations of these 2 interfaces allows you to have full control over how the data are being processed. Basically, you get to the JSON-P implementation, and you are basically working with JSON-P object, with JSON generator or JSON parser, and it is up to you how you read that some part of the document or how you generate Java objects out of some document. So I think that was all from me for now. And if you have any questions or something, feel free to ask.
You could move back on the slide when we introduced JSON-P at some. It was quite early.
Which one?
It was just when you turn to yes, this one.
This one.
It had an error to the data, literal data. The slide had an error from the JSON object to the read key. I don't remember.
Which one? This slide?
It had an error.
Oh yeah, this one.
Yes, this one. So we say here that we create a pointer, right? JSON pointer.
Yes.
1/read. And then we feed this read object with the docs.
Yes.
So what is docs?
Docs is JSON array, so it represents full.
So this is the docs.
Yes, both docs contains both values. It's JSON array, so an array containing both.
Yeah, but okay, so this data is the docs, right?
Yes. This,
You don't have a name, that's why I can.
it's, well,
Okay.
okay, any other questions?
Is it faster than Jackson or JSON?
That's a good question. We have some information that default or reference implementation is not faster, but it's one of our main goals to make it on par. But I think that the most important takeoff from this presentation should be that there is some JSON-B, and it's up to you which parser implementation you will use with JSON-B. You're welcome.
Following up on that, are there any intentions from, say, Jackson to actually implement JSON?
I think they are already implementing it, or at least people from Jackson are part of expert group. They have some representative there.
Okay. I haven't seen any, when I'm tracking Jackson very closely, I haven't seen anything they published yet.
Well, it's still a work in progress, so and it is expected to be released in, I would say, around Java 1, 2017.
The reference implementation itself is?
I mean full Java EE8.
Yeah, but the reference implementation itself is also going to be released standalone, and
Yes.
It's intended to be usable standalone,
Yeah.
right?
Yeah, that's the goal. Currently, you should be able to download the reference implementation and use it.
That's part of the project?
It used to be, but it is currently being migrated to separate project, separate repository. It will be, or it should be hosted under Eclipse Foundation as a separate project. It will be definitely mirrored to GitHub. So you should be able to find it on GitHub, I hope within like 2-3 weeks at most. The guy working on this is currently presenting the same presentation in Sofia, so when he gets back, then he will continue on it. You're welcome. So if there are no other questions, then thank you for your attention.